This video is about hypothesis testing. Before we further proceed, let's have a quick look on the regression result. We can see that the coefficient estimate of beta 1 is 0.09 and coefficient estimate for beta 2 is 1.01, which are slightly greater than 0 and slightly greater than 1. But we know that it's not sufficient enough to conclude that the true parameter value of beta 1 and beta 2 is greater than 0 or greater than 1, because the coefficient estimate itself is a random variable. So to make any meaningful conclusion about the true parameter value, we're going to need invariance. So let's start with the first hypothesis testing. Can we describe the IBM as an aggressive asset? Since we see that beta 2 hat is slightly greater than 1, it's quite normal to ask if the true parameter value is can we safely conclude that it is greater than 1. So it's equivalent to an right tail test, because we are going to set the null hypothesis as the beta 2 is smaller or equal to 1. So we need to compute the t statistic. Please note that we cannot use the t value in this summary regression output in this case, because our hypothesized value is not 0. Our hypothesized value is 1. By default, it's going to the t value provided in R is for each parameter is set it to the hypothesized value is set to be 0. So in this case, we have to compute it ourselves. You can choose to copy the coefficient estimate and the standard error manually, and then compute the t-stat. But I don't recommend this way, because first of all, the coefficient, the values printed is rounded, so some decimal might be trumped, and second of all, you might make some typo. Therefore, I recommend instead of print out the summary and then copy it, you can store it into an object like tem123, and then you can see the coefficient is basically it's a matrix object that the same as the regression result. So for the beta 2 hat is the second row first column, right? So second row first column, and and for the standard error of of beta 2 is second row second column. And then we compute the t-stat again, and as you can see, the t-stat value is quite close, but it's not exactly the same. It's due to the preciseness of the rounding issues. So let's further proceed. Now we have the t statistic. There are two approaches. We can compare the t-stat with the critical value, and then we can compute the p-value and then compare against the significance level. So let's do it one by one. So if we are compared with the critical values, we're going to need so we are going to need the critical value first, right? We're going to for each distribution, t normal binomial distribution, they have the corresponding density distribution function, quantile function, and also a function to generate the random variables. And began with d prefix d p q r. As you can see, if you want to see binomial function or beta function, they have their own way. And for t distribution, we can simply use qt So since it's a 5% significance level, we will use 1 minus 0.05, and then the degree of freedom is like we see from the regression result is 196, and then we generate the critical value. As the sample size is large enough, like we can compare with the normal distribution as well. Like you can see the critical value for Q norm, like as the sample size grow, like the two critical value is quite close. And if we simply use if we are simply comparing it as comparing the t statistic with the critical value of the t distribution, this statement is false, so we cannot reject the null hypothesis that the beta 2 is smaller or equals to 1. So in this case, we cannot describe the IBM as an aggressive asset. Second approach is the p-value approach, right? I made a mistake on the actual computer lab session, if we look at the density distributions, sorry, not density. If we look at the distribution function, like below, yeah, the lower dot tails. We're going to for right tail test, we're going to the p-value comes from here, right? So it's either way, like we provide the lower dot tail equals to false, or we use 1 minus this way, this value. So so we can see that the p-value, if we set it to lower dot tail, is 0.45. It's the same. And if we would like to like see if this statement is true, is false, so we cannot reject the null hypothesis, as the resulting p-value is greater than the significance level. So this is for right tail tests, and I will continue for other hypothesis testing.